need to review eyes with you guys because you may not remember them from anatomy or from A&P. So let's quickly review how your eyes work, what the structures that I care about do. So, from way back, whenever you did this before, we're not going to find all the structures that you learned in anatomy because I don't care about all of them. I only care about the stuff that helps you actually see. So we'll just do some of it. So remember this part way on the front of the eye? That's the part that if you touched your eye, you would touch. That was called the cornea. And then right behind there, there's like a fluid-filled pouch right here. And so this has liquid in it. And then behind that, this is the lens back there. And the lens is connected to some muscles. You remember from anatomy, those are called ciliary muscles. I don't care you remember their name, but what they do is they pull on these guys. These are like little ligaments. They pull on those to change the shape of the lens. So the ciliary muscles are going to pull and push on that lens to change its shape. What the lens does is it gets either fatter or thinner, depending on how far away something is, which I'll explain in just a second. So, lens there. Both the cornea and the lens help you focus the light that's coming in, the image that's coming in. And so what's going to happen is, like, let's say you had a letter X out here. When you are seeing something, the reason why you can see something is because the light that shines, like if you're staring at this cabinet or this flag, let's say, if you're looking at the flag, the reason why you can see the flag is because the white light that shines on the flag, some of it is reflected off the flag and into your eye. So it's actually the light rays bouncing off this object that you're seeing. And so in this case, there's red and white. White means all colors of the rainbow all together. The way that we perceive all colors of the rainbow in equal proportions is it looks white. And then blue. So different colors are reflecting off. Red reflects off, everything reflects off in these spaces, and blue reflects off in these spaces. So it's like white light came and hit this X. And then some of that light bounced off of it and went into our eye. And what we need to do is we need to focus that light back here on what was called the retina. So the retina, and especially right at this point on the retina, if you remember from your other classes, that was called the fovea centralis. There's that area of the retina has the best visual acuity. That means you see things best right there. It gets the clearest focus. So in order to focus light rays, what you have to do is, if they're all coming off this thing, you have to bend the light rays in order to make them focus. And kind of what I like to use as an analogy is, if you guys, it's actually not an analogy, it's exactly how it works. If you guys have ever played with a magnifying glass with the sun, and so the sun shines through the magnifying glass, but then you can get it, if you move the magnifying glass at just the right distance, you can get it to make like a little light point on the table or the ground or whatever, like, you know, frying ants. Your magnifying glass. Okay, so like that. That's exactly what's happening with your magnifying glass. The sunlight's coming through like this, straight down. But when it hits that solid glass, the light rays bend inward and make that little focal point. That's exactly what you're trying to do here. The light rays coming off that flag or this X are going straight in, but then you need to bend them in order to focus them, like, think like the little tiny frying the ant light right there. That'll get you a focused image. With a magnifying glass, the way to do that is to like move it up and down, right, until you get it right at the right spot. The magnifying glass is like your lens, but we can't move our lens forward and backwards. It stays in one spot. So there's another way to focus light rays, and that's to make the solid structure thicker or thinner. If you could do that with your magnifying glass, that would work too. If you could thicken the magnifying glass or thin it out, you could focus it even though it's staying in one spot. So it's kind of like the eye's way of moving it forward and backwards by making it thicker or thinner. So we're going to change the shape of our lens depending on how much bending we need to get it to focus on the retina right there. So here's the rule. The closer an object is, the more bending you need to do. More bending of light. So by close of the object, I mean how close is the object to your face? The closer it is to your face, the more you need to bend that light to get it to focus right here. Yeah.
Is that like what like bad vision is?
I'll get to that in a second. That's what you're going to test your vision today. Okay, so how do you bend light rays more? You bend them by forcing them to go through more layers of stuff. The thicker this lens is, or the fatter it is, the more bending you're going to get. So if this is the case, make the lens thicker. Fatten it up. That'll bend the rays more for you. The more solid stuff that light rays have to go through, the more bending is going to happen. There is a little bit of bending that happens on the cornea because that's a solid structure too. But that is always the same thickness, right? You don't change the thickness of your cornea. So that's kind of set. That amount of bending is set. And the only thing you can really change is the lens thickness. Okay, so then vice versa. Farther away something is, farther away, less bending needed. To get it to focus right here. And therefore, you're going to make your lens thinner. So these are the rules of focus. Closer something is, the thicker your lens needs to be to focus it on the retina.
And the ciliary muscle controls that, right?
Right, the ciliary muscle controls that change in shape of your lens. And it's done automatically. Your brain figures it out on your own. It's not like you have to think, right? Oh, this is getting closer to my face. I better thicken my lens, right? You don't think that. It just, your brain sees it coming closer and it adjusts. That is something that is a reflex, and it does slow down as you get older, and especially if your eyes are just so-so anyway. You know, some of you guys maybe not, but for me, for sure, sometimes if you've been like reading something close up for a while, when you first look up, the things far away look blurry. That's just the ciliary muscles getting the message that you're no longer staring at something that's close to your face, and you need to readjust the shape of your lens. That slows down. Sorry. Sorry to let you guys all know that, but it does slow down the older you get. It takes a little longer to adjust your focus sometimes if you've been staring at something for a long time, one way or the other, far away or close up. Okay, but it should automatically, your brain should tell the ciliary muscle what to do with this thing. Thicker for closer, thinner for farther away. Okay, so what if you are nearsighted or farsighted? So like what you asked about vision. It's going to be off the screen, but I didn't want to erase that. If you're nearsighted or farsighted, so nearsighted, the technical term for nearsighted is myopia or myopia. Either way, here, let me just do that. Then I don't hit Kaylee. And what's happening if you are nearsighted is that, or farsighted, either way, is that the actual shape of your eyeball is different than normal vision. So in this case, this is normal vision and a normal vision eye. This dotted line is where the focal point needs to be on the retina. And they run the dotted line all the way down so you can see the differences in the eye shape. In nearsighted or myopia, the actual eyeball is slightly elongated. So your retina is actually a little bit farther back than it normally would be. It's not like your eye is like totally distorted and going back into your skull. It's a very subtle size difference. But it's enough to kind of throw off the focal point thing. You know, imagine if you were trying to burn ants and all of a sudden the table moved farther away. You wouldn't be focused anymore, right? Your little light source wouldn't be focused on the ant anymore. That's kind of like what's happening. So in this picture, it's showing you at a given lens thickness. So let's assume this lens is normal and this lens is normal. Then what's going to happen is as these light rays bend in, we're going to fall short of the retina and everything's going to look blurry because you're just not quite making it. So what do you have to do, like, to fix this problem? You need to bend the light rays a little less so that they don't focal point too quickly. You want to spread them out a little bit more so that they do actually make it all the way to the back of the eye. So let's say you're just mildly nearsighted. Okay, let's say that I was just mildly nearsighted and I'm here and a normal person is here and we're both looking at you guys out there. My lens, in order to focus on you guys, would have to be a little bit flatter than this person's because I don't want to bend the light rays quite so much. And that's how somebody who is mildly nearsighted can get away with not wearing glasses because the lens just accommodates it. And so where this person would have maybe this person's lens is this thick, my lens is only this thick. It's just the ciliary muscle in the brain kind of accommodating for the fact that my eyeball's a little bit long and everything's looking too blurry, so flatten it out a little bit. So just mild differences in length, you can accommodate that because the lens, you know, it does change shape and we can fix it. But, you know, if you think about it, why is it considered nearsighted? Nearsighted means that it's easier for you to see things close up than far away. So, and it kind of makes sense if you think about it, because remember that farther away means making the lens flatter, and your lens only gets so flat, right? Remember that my lens, like looking at you guys, it's already a little bit flattened. If I then try to look back at the cabinets, I may not be able to get it flat enough to focus way back on my long eyeball. That's when the problems start. And it depends, you know, the longer back this goes, the more that's going to be true. The closer and closer you're going to need something to your face before you can see it. If you take, for instance, my husband is extremely nearsighted, and he has, like, gigantic glasses, right? But he can take his glasses off, and he'll hold something up to his face like this close. And he can see it. He can read it like this. And he's really good at seeing really tiny things really close up to his face, but he literally, one eye's closed and he's like, yeah, I can see that. And like that's where his lens is as flat as it gets. Any farther than that in the lens, you can't take the lens out. You can't take the cornea out. You know, there's no less thick you can get. And so what the glasses are doing, for a nearsighted glasses actually looks completely different than a far-sighted glasses. So now you can do like the party trick of taking off someone's glasses and telling them whether they're nearsighted or farsighted. If you're nearsighted, you're going to have concave glasses with it thicker on the edges than it is in the center. It's going to be more obvious the more nearsighted you are. If you're just barely nearsighted, it's really hard to tell that. But if you're, you know, like if you look at my husband's glasses, these are like the stereotypical Coke bottle glasses, like the bottom of a bottle where it looks like it's caving in. That kind of look with real thick edges on them. Okay. The reason why is a concave shape. Instead of bending light rays, a concave shape will scatter light rays outward. So this concave shape in front of your eye will spread the light rays out for you a little bit before they come in, so you're not over bending them. It's like helping to scatter them for you first. before they come in, and then you can go through the cornea and the lens and not fall short.